Thank you for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Hello, everyone, and thank you for joining us today, and welcome to today's webinar from our Standards Activities Board series from the IEEE Cybersecurity and Privacy Standards Committee. My name is Scott Levine, and I'm the Membership Manager here at the IEEE Computer Society. Before we get started, I would like to address some housekeeping items. This webinar is being recorded. You can ask any question in the Q&A box you see on your screen. Eric Hibbert, our guest speaker today, will answer as many questions as he can following the presentation. If possible, please reference the slide your question refers to. A copy of the slides in the recorded webinar will be emailed to you tomorrow as well. Here at the IEEE Computer Society, we're dedicated to promoting the development of standards related to security. The IEEE 2883 2022 IEEE Standard for Sanitizing Storage provides detailed guidance and requirements for the proper way of eradicating data on storage devices and media. Keep up with our ongoing calls for participation with IEEE standards and get involved with the Standards Activity Board. As part of this network, you have the opportunity to connect with professionals from all over the world, expand your knowledge with the Computer Society Digital Library, which features over 685,000 papers and articles highlighting the latest in data storage and related research. Furthermore, you can grow with other professionals through various events such as technical communities, conferences, and student and chapters. Information will be shared with you after the webinar, and you can always learn more at computer.org. Circling back to today's presentation, there is a general understanding that systems and data both have life cycles that typically include a disposal phase. And conceptually, data needs to be eliminated either on a system or entirely as part of this disposal. Failure to correctly eliminate certain data can result in costly data breach scenarios. However, securely eliminating data on storage devices and media can be a challenge. This session outlines the various forms of sanitation techniques and methods covered in IEEE 2883. And so joining us today is Eric Hibbert, who is a senior security and privacy professional with expertise in a wide range of technologies. He is the chair of the IEEE Cybersecurity and Privacy Standards Committee. Eric also holds leadership roles within the American Bar Association, the Cloud Security Alliance. I'll let Eric finish and introduce himself on his many related knowledge and background and expertise in this area. Eric, thank you for being here today, and the floor is yours.
Thanks, Scott, and apologies for running you through the barbed wire of that introduction. So as Scott said, I am very active in the standardization space. Some people call me a standards geek. Relative to this presentation, I've been actively involved in the IEEE 2883, and there's an ISO standard on storage security, which is very related and under some revisions right now. And so what we're going to talk about today is an area that is very a hot topic for not only the security space, but also for sort of eco kinds of environments, the circular economy. So we hope that this new work is something that will be useful on a couple of different fronts. Making sure the slides are up here. So Scott, if I'm trying to make sure this slide is on the screen.
Yep, it's on the screen.
Okay. Okay, so I'm going to give you a little bit of a background. And we're going to start with lifecycle management. Okay. Dealing with lifecycle management, data lifecycle management. This is important because it basically sets the stage. And you'll see that you've got the concept of create, store, use, share, archive, and destroy. The destroy piece is the element that can be the most challenging, because if you think about it from an overall data perspective, it's not just a matter of where it's on maybe a single piece of storage device or media. It's basically all copies of it, and that can be a difficult process to deal with. Where is it located, and how do we make it go away? And we see in certain spaces that's a particular concern in making sure all copies are gone. In some cases, how you get rid of the data is also an issue, because there may be some compliance obligations around it. You may have to retain it to a certain point, and then you have to get rid of it, and you may have to be able to demonstrate that you've gotten rid of it. So this data lifecycle management is something that many organizations are having to deal with. In the case of storage, however, there's a different sort of life cycle, and in fact, what we're trying to see happen in the circular economy for storage is a scenario where it's manufactured and it goes through and is used, and at some point you're able to get rid of the data that's on that storage, and then maybe it's reused, it's repurposed, and then ultimately back through where you recover the components and whatnot. Unfortunately, what we're seeing right now is that this circular economy is not so circular. It's basically manufacture, use, store somewhere, and then destroy, turn into dust or something of that nature. And that's part of what we really like to see. That cycle maybe be extended a bit, and there's often a lot of rare earth metals that are in some of these storage devices and the media, and we'd like to make sure that those kinds of things are recovered to the degree possible. All right, so when we talk about destroying or eradicating data, and we have to sort of use somewhat precise language, because you'll see there's a lot of so words that are used around this that have been abused. So when we're talking about this, data eradication, this is something that's not easy to do. You basically have to get rid of all copies if you're really going to get rid of it, and this means backups and images and temporary copies. Lots of places that you wouldn't even think to look at, you've parked the data somewhere, and you got to go find all of them. Storage technologies are particularly good at making copies that are not necessarily visible to you to guard against loss, and so you have to sort of account for that. You may have to have records in terms of what you did and how did you take reasonable steps to make stuff go away. And you also have to be aware that there are some pretty advanced forensic tools that are pretty good at being able to recover data, especially if you haven't really used the right sort of technology to make this stuff go away. So what you do is often driven by the sensitivity of the data. So if it's the cafeteria menu, you're probably not going to be too worried about it. But if it's trade secrets or government secrets or things of that nature, then the sensitivity is really going to drive the efforts you undertake. You also look at the potential harm, and that could be to a nation, but it could be to individuals as well. And so it's important to factor that in terms of what exactly you're dealing with here. All right, so I mentioned that there's some confusing language around this stuff. So you see things like data deletion, secure data deletion, which is one of my favorite ones right now. There's some language in some European standards that use this term. Data shredding, data wiping, data overwriting, data erasure, data clear, data destruction, and the last one is data sanitization. And if you go and look, very few of these actually have any sort of technical specification to them. The one in blue, data sanitization, there are some definitions around this, and I sort of walked you through some of the things you worry about. But because this language is somewhat squishy, if you get into a situation where, we did data destruction, so what exactly, is that? If there's any sort of legal challenge or a regulator comes in and gets involved, then you have to explain exactly what you did, and it turns out you may not have done the right things. So we are trying to add some precision, and this is one of the things that the IEEE 2883 and then the ISO standard 27040, the IEEE standards dealing with storage sanitization, the 27040 ISO standard is storage security. So what is sanitization? Well, it's a process or method to render access to target data on storage infeasible for a given level of effort. Okay, so you have to sort of parse this down. What do you mean by access? Well, the data might not exist anymore. The storage device may not exist. Or there may be something that permanently blocks or prevents access to the data. So this is a little broader sort of way of thinking about this than just, we made the data go away. Well, there's as you can see, there's multiple ways that you can do this. The term target data is also important because it may not be just user data. There might be metadata there that's also important. And again, it's somewhat dependent on the nature of the storage that's being used, and of course the sensitivity of the data. So there may be some hints, metadata as to what it was, and even that may be considered sensitive. Infeasible for a given level of effort. Well, that's a fun phrase. So in many cases, there are not necessarily obsolete black-white kind of lines here. It's shades of gray in terms of what you're able to do. So, for example, if you're using cryptography as a mechanism to sanitize, the strength of that cryptography may be good for the next 30 years, but the data may be sensitive for the next 50 years, and so you've got to worry about is that kind of a protection going to be adequate for what you're making go away. So this infeasible is really looking at how hard is it for an attacker, a vigilant attacker, well-funded attacker, to try and recover the data. Okay, so moving on to forms of sanitization. And again, we're looking at this from data sanitization. So this is looking at, all instances of the stored data and wherever it sits. So this is the data lifecycle management destroy kind of thing, versus storage sanitization, which is really focused on making data go away on your information communications technology infrastructure, and in particular, what we call non-volatile storage. So that's storage when you turn off the power and turn it back on, it's still there, as opposed to volatile storage, where if you turn the power off, it goes away. So we're really focused on the non-volatile piece. And what we see is there's basically logical sanitization and media sanitization. Logical, you can think of that if you're using, for example, cloud storage. You don't actually have access to the underlying media or storage devices, but there is, a non-volatile storage capability. Media is just as it sounds. So this is, you've got a particular device. It could be something like one of these little SSD kinds of things. Takes many different forms. All right, so common aspects of storage sanitization. So what's involved? Well, first off, you've got to identify what kind of storage that you're dealing with. This is usually the determination of is it logical or is it media based, and that's going to play heavily into terms of what you can basically do. You then have to select a particular method for how you're going to deal with the sanitization. You got to execute a particular technique, and then you need to verify that what you did actually resulted in the data being eliminated, that there's or that it's adequate, and there may be sort of a risk assessment that you have to do. Is like, so if you cut it up into pieces, are the pieces small enough relative to the sensitivity of the data? And then last but not least, you may actually have to have some sort of proof that you actually did it. So you could go through all these other steps if you fail to record it, and you've got compliance obligations. You may actually be in trouble, same amount of trouble as if you had done nothing at all. All right, in terms of methods, since I mentioned that, they really come down to three basic methods: clear, purge, and destruct. And we'll talk about these in a lot more detail. Clear is basically a logical technique. So this is your trying to replace data on all the user addressable storage, right? And so it could be something as writing zeros or ones in all the locations that you potentially have access to. The end result, however, is that the media or the drive is basically usable. Purge could be physical or logical techniques, and really the focus is protecting against state-of-the-art laboratory techniques, and those can take a bunch of different forms. But think of this as techniques that nation states could use, or possibly organized crime, or forensics, advanced forensics kinds of applications. If you've done a purge, then the data should still, well, not should, the requirement is that data is definitely still gone. Even if you've brought out an electron microscope, you're not going to be able to get it back. That's the basic concept. And then the last one, destruct, is basically it's definitely a physical technique, and again you're essentially using one of a few approaches to making things go away. We fondly call this is the Sparky phase. So you get some guy that historically might be grinding up a drive, but what we're finding is that may not be in itself completely adequate. All right, so I mentioned state-of-the-art laboratory techniques, and just to kind of give a few words on this. If you're familiar with hard disk drives, this could basically be removing some of the electronics associated with that hard disk drive in an attempt to bypass mechanisms that may be preventing access. Could be putting the platters on a spin table and a spin stand and doing analysis on that. You could do wash my tongue today. Microscopy. You could do X-ray probing. Lots of these techniques. These are not cheap techniques to employ, but they do get used, especially if the data is considered high value. All right, so in terms of selecting a sanitization method, this is an area where the current state of standards is challenged. So basically, you have to sort of factor in some general considerations. So the sensitivity of the stored data, if there are organizational policies or maybe a risk appetite. So if you are, for example, financial institutions are extremely concerned about any data about their customers or operations, and they tend to destroy the drives. So they have a very low risk appetite, and their policies may dictate that that's the only thing they're allowed to do. And of course, we definitely want to see the environmental impacts factored in. This has been an area that has really not received the attention that it probably should have in the past, and so we're definitely sort of bringing this to the attention of those who are looking at sanitization methods. The general recommendations as part of this selection process is, you want to guard against data breaches due to any sort of media handling kinds of issues. If you're handing off drives, for example, to a third party, making sure that you've done that in a way, just simply transferring it to somebody else could invoke data breach protocols if, for example, it leaves your site or something of that nature. We really want to recommend, avoiding destruct, if at all possible, because that basically pretty much ends the circularity cycle when you're down that path. And in sort of follow up on that this is where the purge and particularly cryptographic erase, and we'll talk a little more about what we mean by cryptographic erase here. So in the IEEE 2883 standard, which was published in September this year, it has this diagram flow, and you see what we're trying to highlight is if the process you're using sort of in that green box, then the idea is that that's an eco-friendly process. But again, due to the nature of the data on the drive, that may not be an option. Also point out that you see this clear, purge, and destruct on the left-hand side. So you as an organization are going to make a basic starting point in this process. So you may start with clear as your, we think this is an acceptable type of method of sanitization. And then the 2883 standard will then walk you through the process, because it may turn out as you try to use specific clear techniques that they're not working, or they're leaving residual data that's unacceptable. And ultimately you may progress to a purge, and even that may not be adequate, which then may lead you to a destruct mechanism. So once you enter this process, the 2883 standard will help you arrive at the right sort of end state, if you will, and then deal with things like the whatever kind of evidence you need to produce, and even give some recommendations on verification. But this process is it's important to figure out where you want to enter it, and then once you're there, the IEEE 2883 standard definitely will help you sort of work your way through it. So I'm going to move on to some sanitization techniques, and give you some ideas of how to deal with those. All right, so factors affecting your ability to sanitize. This is kind of back to that selection process. If you don't know what the media is, you've got a fundamental problem in that you're not really going to be able to tell from a clear or purge perspective what you can do to eliminate the data. And this could take a lot of different forms. You may have tape cartridges that aren't labeled. The shape of the cartridge doesn't tell you what it is. You may have storage in, for example, a copier machine. You can't really get at. It may be sealed. Could be it's in a laptop. So there are definitely times where you may not know what you're dealing with, and if that's the situation, you may be forced down the destruct path. Unfortunately, that's where a lot of the roads lead. If you don't know what it is, you don't have the expertise to deal with it. If it's not in some sort of operational state, if it doesn't power up or doesn't boot, you may not be able to do anything to it. Or you may not actually have the tools necessary so you may know what it is and it may be operational, but you may not have the software or hardware that will let you go in and do like a clear or purge kind of operation. And all of those, unfortunately, will quickly lead you down a path of we can't do a clear or purge, we're ultimately going to have to do a destruct. Right, so this is another way of sort of showing you that there are these other techniques under each one of these options. As you can see, the clear and purge are what we're tagging as eco-friendly. Ideally, you would be able to use one of those techniques to get rid of the data that needs to be eliminated. But it's not always the case, and we recognize that. So, but in the IEEE 2883, we do try to give enough options to make clear and purge a palatable choice. All right, so looking at specific techniques, there's the concept of overwrite, and overwrite, again, from a storage industry perspective, can be an overloaded word in that you might actually equate overwrite to just writing ones or zeros on every user addressable location in the storage. However, there are some technology-specific commands that are called overwrite, and they may actually not only be a clear operation, but there may actually be a purge equivalent of those. So when you're talking about overwrites, then it's important to know exactly what you're doing. And 2883 is very, very helpful with that, because it gets into, as you can see here, what your options might look like when you're doing overwrites. Now, overwrites, especially if you're just like writing ones and zeros, it can be somewhat cumbersome, depending on the size of the storage, if you will, the capacities, but it doesn't necessarily work well. So, we look at paper and certain optical media. These non-magnetic media, overwrite doesn't work very well. if you think about paper as an example, not really very easy to overwrite paper. I guess you could like take a black marker, but even that's not necessarily gonna take care of it. And certain NAND flash. So and we see flash showing up in cache. We see it like in SSDs and things of that nature. So overwrites often are not going to be a technique that will get rid of all of the data, and part of that's due to over provisioning. So there's more storage than what appears to be addressable, and that's part of the complication. So another technique that shows up is Blocky Race, and this allows to eliminate fairly large regions of the storage. It's not appropriate for magnetic media. It's definitely useful for, like, for example, NAND and SSDs. So this is, again, one of those techniques that we definitely see being used. And 2883 goes into the details on exactly how you will go about doing that particular technology. Next is cryptographic erase. And this one, conceptually is pretty straightforward to understand, but there's some preconditions. So at a basic level, what you're talking about doing here is you've encrypted whatever it is you've recorded. And the crypto erase is essentially you destroy the key that was used to encrypt the data, and therefore you no longer have the ability to decrypt it. So the theory is if you used appropriate encryption algorithm, something that is not going to be easily broken, that it should not be possible to decrypt this. So what happens is you've got random bits on the media, the ciphertext, and no way to recover it. So that's the basics behind it. Of course, that assumes that the encryption key is gone and all copies of it are gone, so that there isn't a recovery mechanism available. And you see a lot of self-encrypting media go to great lengths to try and deal with that kind of an issue. However, for this to be usable, first and foremost, whatever it is you're gonna try and use cryptographic erase on, it has to be encrypted. So and if you actually started using media without using encryption, and then went oops, and then turned on encryption and started writing data, well, anything had previously been written to the storage is not really going to be covered by the cryptographic erase, and that's a problem. Again, I mentioned the strength of the encryption is an important element. So you don't want to be using something like the DES encryption, which could take a high school student maybe an hour or so to basically crack. You want something a little stronger than that. Maybe AES, probably at least 128 bits, key size, but preferably 256. And if you're doing that, then cryptographic erase is a very powerful tool, because it's a near instantaneous kind of operation. In terms of producing evidence, what you need to be able to demonstrate is, yes, the data was encrypted, and look here, I basically destroyed the key, and it's those kinds of transactions that you can record as part of your evidence. All right, and so again, IEEE 2883 relative to cryptographic erase is focused on only the media-based piece of it. The ISO 27040 standard, as was mentioned here, some of the preconditions looks at in a broader sense. So, for example, cryptographic erase can be a very powerful tool with the logical virtual storage. If you know you've encrypted all that data and you have the ability to destroy the the keys. So again, this level of effort kind of phrase comes out again. So this is part of do you match the key sizes and algorithms to the value of the data or the harm that could be realized if the data is released into the wild. And you want you want to be able to use a technique like this in a scenario where speed is of importance. And to give you a hypothetical, if you're flying an aircraft in enemy territory and you're being shot down, you don't have 2 weeks to basically use an overwrite or other purge mechanism to make data go away. If it's in terabytes or petabytes of storage, you might have 5 minutes to get rid of that data. Something like cryptographic erase could do that in seconds. And so this is one of the techniques that was developed to deal with those kind of situations where speed is of essence. But it carries over into everyday life, in organizations where can you afford to have storage systems that have petabytes of storage sitting idle for weeks while you go through and do overwrites, multi-pass overwrites on each drive? The answer is probably not. So this is where something like cryptographic erase comes definitely into play. And you can actually combine it with an overwrite. So we see some organizations, they'll use cryptographic erase and then they'll come in and do maybe a one-pass overwrite. Adds more time to it, but if you're a belt and suspender kind of organization, that's one way of adding some additional assurance that you know the actual state of the storage on the other side of the sanitization operations. All right. All right, so let's move on to destruct. This is where Sparky comes into play. So we've got definitely some techniques here. Melting, which I think we're all basically familiar with what that concept is. But when you're talking about storage, media, and devices, I mean, you really are turning it into liquid state. This is an application of heat, maybe lasers, I don't know, but it's your net result is basically a puddle. And the next one is incineration, and basically you are turning whatever it is into some form of ash. And then in the past there have been even specifications of what that ash might look like, but as media has kind of changed over the years, that's not completely appropriate. Obviously, these two techniques are not really all that green. I mean, you're using a lot of energy to basically do either one of these approaches. It's going to render whatever materials there are essentially going to be hard to recover, if at all. And you still, the outgassing from the materials when you apply the heat, could be toxic materials that get put into the air. So again, these are a couple of techniques from a destruct perspective that are still approved, if you will, from a 2883 perspective, but as we're showing, they're definitely not eco-friendly. There are a couple other techniques, shred and pulverize, which what we're discovering is that these have basically really have entered a zone where they're somewhat deprecated. So think of shredding as the word implies. You may be familiar with a paper shredder where it's worried about things like crosscut, and basically it's the size of the resulting particles. And there are actually devices that will shred a hard disk drive, just cut it up into the chunks. The problem is, if you look at the resulting chunks, you may be able to look at one of those pieces and recover a significant amount of data in the form of gigabytes of data, just because of the density. And as an example, a Blu-ray disc is extremely dense, and if you have a 2 millimeter by 2 millimeter chunk, the amount of data you could recover is quite high, and that's a problem. So we're seeing shred even down to a size of 2 millimeters is just no longer appropriate because of the densities that are being used. Pulverize has kind of a similar problem. You get it down to dust. All right. So let's say that you get it to that level. But we're now seeing storage taking the form of DNA. So it might already be dust. So pulverizing it is really not going to be all that practical. It's already at a state where that's fine, no problem, still recoverable. So we're in 2883, both shred and pulverize have been identified as techniques that you definitely want to understand your risk appetite for their use. All right, so I'm going to move on to verification and documentation, because these are some important element of the standardization process. All right, and so let's start with the verification. So if you're dealing with storage, you may think you have finished, but are you really sure that the device did what it was supposed to do? And you're only going to know that if you actually try and do some form of verification. And it turns out that verification actually can be pretty tricky, depending on the technique that you're using. And let me pick on cryptographic erase. So in theory, you've destroyed the key, and so what you've got on the drive is random bits. All right. Okay. Well, remember that storage is vendors are very persnickety about, and I live in this space, about error checking and all kinds of things, right? So when you cryptographic erase that content, you may have also had an impact on the drive's ability to do error checking and whatnot. And so when you go to sort of read the content, the drive may actually be in a state that it is not able to report back the random bits that's on the media, because when it goes to read it back, the error codes, the error checking, may give an indication of some sort of failure. So, in this particular case, you did the right thing, but you may actually not be able to get the bits back to even inspect, is it random? And so this causes some problems. And, it can even come into play with a clear, depending on the kind of technology you have. So usually for clear and purge, you're trying to use the interface of the device to inspect, the net result of what you did. But because of the particular operation, the technique used, the device may need to be basically reset, reformatted, something of that nature, before you can actually do anything. So verification can be, you have to think it through carefully, to actually do it. In the case of cryptographic erase, it can be, tricky to do that. In the case of destruct, you're clearly not going to use the interface, because if you've done it right, you've destroyed it. So this is a physical inspection. You actually have to look at it. Are the pieces, if you're using shred, are the pieces, the size, the maximum size that your organization is going to accept. Okay, so in terms of documentation, this is one of those where you did all the right things and you've got a compliance obligation and you just didn't do the paperwork, or you did the paperwork, but you didn't retain it in a way that it's going to be consumable if there's ever a question, an audit, regulator comes in or something of that nature. The 27040 tries to help with this in terms of what would you potentially need to capture, at least in terms of the record, or as we call it, the evidence of the sanitization. And so when did you do it? Who performed it? And the list is pretty straightforward. There shouldn't be any really surprises here. And the other piece of this is, so how does this stuff get recorded? And we see basically there's two approaches. One is in the audit log, of whatever the IT is or the ICT is. And if you take that approach, then it becomes important to retain that information, because that has become your evidence, if you will. Another approach is a certificate of sanitization. So as the process is being executed, somebody is actually entering detail into maybe a little application that will then produce either a digital record or maybe print it out for the whatever the storage is that you're dealing with. So it includes things like the serial number and whatnot. And this can be particularly important because if one of these drives shows up on one of the eBay or Google or whatever for sale, and there's ever any question as, oh, that came from us, because you may be able to trace it back to who may have previously owned it. And there's a question about, was that sanitized or what was it used for? Then these records become instrumental in terms of, yeah, we did what we needed to do. We did our due diligence, due care on this, and we don't really have a problem per se. Okay, so I know this has been a bit of a whirlwind tour of sanitization. If this is something that you're absolutely interested in, and obviously I've said 2883 is going to be very, very important to you. What I'd like to do now is talk a little bit about some of the standards and sort of put them in a context that maybe helps with why you care. All right. So in the world of sanitization, there are some standards that aren't worth taking note of. So if you're into security, you are probably aware of the ISO 27000 series. Organizations go and get certified against 27001 for their information security management systems. There's a companion standard to that, ISO 27002, which is basically information security controls. It was published, the latest edition was published in February of this year, so fairly new, massive changes to this document, and it's often used by auditors as part of the 27001 certification process. All right. And very, very useful document in the NIST space. The NIST special publication 800-53 would be a potential, equivalent to the 27001 and 27002 pair from ISO. Now, 27002 points at 27040 for some particular areas. Sanitization is one of those. Another one is backups. And you see I've got 27040, the 2015 version, soon to be obsolete. Well, what do I mean by that? Well, we've been doing a revision of 27040 for over 2.5 years, and we expect the new standard, which you see down here under draft standards, will be published in Q1 of 2023. And I can say that with some level of confidence, as I am the ISO editor, and I'm actually working on the final draft international standard text, processing some comments from the recent ballot of the draft international standard. Obviously, 2883 is an important beast in this space, and work continues in that arena. We are not done on the IEEE side with this. You know, I mentioned challenges with verification, but there's a bunch of media types that we didn't necessarily deal with at this point. So we're anticipating that 2883 is going to be refreshed on a relatively fast rate. I would be shocked if it's not revised on about a 3-year cycle, just given what I know about the storage industry. And there has been a NIST special publication, 888, revision 1. It's on media sanitization. It and the original 27040 were absolutely synchronized in terms of the techniques that went in. The new 27040 is basically stripped out all of the technique information. Something about, you know, the relevance of iPhone first generation, zip drives, floppies, lots of obsolete technology were covered in both the NIST document and 27040. So what we're seeing now, and it's sort of the very bottom here, you see I've got 27001 is basically pointing at 27002. 27002 is pointing at 27040, and 27040 is definitely pointing at 2883 with regard to sanitization. Now, the reason this is all important is look at the dates of these documents. So 27001, I've got it marked as 2022. I'm a little optimistic. You should be able to buy this new version in probably the next 3 weeks, maybe 4 weeks. This is going to send a shockwave through the security community when this new puppy arrives. But then this linkage is going to be key. And notice 2024 is marked as 2023. So we're projecting that the security community is going to be taking serious note of this sequence, if you will. All right. So bringing it home to sort of the storage world, if you come back and look at, you know, aspects of storage sanitization, where do these standards come into play? Well, identification, you know, logical versus you know, media line, 27040 is definitely helpful in that space, and that's part of the role of you know, 27040 and 2883. And it's been helpful that as the editor of 27040 and being actively involved in 2883, we made sure these standards were very much aligned and complementary, no conflict there. So how to deal with the selection of the method? Well, we have a new project, 2883.1, which has got an approved project authorization request. This is one of the topics that it's going to try and deal with. Executing, you know, the technique, 2883 has definitely got that covered. With regard to verification, this has got some content, some recommendations in both 27040 and 2883. But again, we think the new 2883.1, this is in scope of that new project authorization request. And then, of course, the proof of sanitization is definitely covered in 27040. So few comments to sort of wrap things up here. You know, storage sanitization is definitely an important security control. It is one of the tools to help you avoid data breaches. when you, especially if you lose control or sight of your storage media or storage devices, documentation is absolutely critical. We think 283 is going to be the go-to document in terms of how you go about doing sanitization. And please, 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 please use Purge versus Destruct. You know, as a bit of a teaser of things to come, there are lots of storage sanitization issues to be solved. And these are some of the areas that we intend on working towards in the future. And there are ways that you can get involved. You can join the Security and Storage Work Group within IEEE, which is part of the Cybersecurity and Privacy Standards Committee. And of course, if you're interested in the ISO committee doing some of this work, it's SC27. And there's a lot of cross-pollination that's taking place between IEEE Computer Society. We actually have a Category A liaison relationship with SC27. So this is definitely an area of lots of excitement. All right, so I think with that, Scott, I think I've made my comments. I see you've got a question from, can you talk about logical virtualization storage standard versus media-based sanitization? Does 2883 care which? Is there a preference? So 2883 is definitely focused primarily on the media-aligned sanitization. The scope of the standard does allow coverage of the logical virtual, but at this juncture, it doesn't really address it. 27040, however, the new version of 27040 does identify, what you can basically do there, and what it comes down to is for the logical storage, destruct is really not an option. So you have to either use a clear mechanism like overwrites, or a purge in the form of a cryptographic erase. And that's essentially your major choices with regard to logical sanitization. Media aligned, you got lots of options, with clear, purge, and destruct. And 2883 does an excellent job of covering those. And I think that's the only question I see, unless there's others that sort of pop in here. So maybe to add a little additional maybe incentive to get involved, the work group that developed 2883 and the .1 project authorization request is also exploring the possibility of conformance assessments. So if you're familiar with the FIPS 140 certification program within NIST for cryptographic modules, we're definitely looking at the possibility of doing something like that for media sanitization. Sarah's asked, does the standard address the use of third parties to perform sanitization? So excellent question, Sarah. So we are already seeing, for example, the International Data Sanitization Consortium, which has organizations that actually are third parties doing sanitization, are very excited about 2883 because it's giving very, very explicit guidance with the expertise from the storage industry. So those who know how to do this have definitely been participating. The conformance assessment program that I mentioned is probably more aligned with your question, in that we think that having the ability to run a particular storage device through a program that actually verifies that it's doing what it's supposed to be doing, and it's not just a vendor making the claims that they're claiming, it's somebody else has the ability to do that. So yeah, we're very excited about being able to set up a conformance program. Very early stages on that, so stay tuned. But we think this is something that the industry has been asking for 4 or 5 years, and we don't think it's going to come out of any of the government. So So IEEE is probably a good place to try and actually set something like that up. And I don't think I see any other questions.
Yeah,
Okay.
I was just about to jump in, and that does look like the end of the questions. Eric, thank you for a very wonderful presentation. Lots of great info and the differences between all the sanitization methods. And thank you everyone for attending. I hope you got a lot out of this presentation. I know I did. Quick programming note, the IEEE Computer Sci has 4 additional webinars coming up next couple weeks. The first one is actually tomorrow from our Distinguished Visitors program on blockchain at 7:30 p.m. Eastern. Then on November 1st, we have the next webinar from the Standards Activities Board series on DevOps. On November 10th, we have another webinar from the Distinguished Visitors program on deep learning. And from our Build Your Career series, we have a webinar on how to manage up on November 15th. You'll be able to register for all of these upcoming webinars and some of the webinars from our archive with a link in the email you'll receive tomorrow. The email will also have this recording and the slides from today's presentation. Again, I would like to thank Eric Hibbard for joining us today and for all of you attending and for our great Q&A discussion. Thank you again and have a great rest of your day.